We welcome you all to today's webinar on the topic Durable Concrete Looking into the Future. This webinar is organized by Civil Engineering and Construction Review, powered by River Media Private Limited. We are honored to welcome our distinguished panel for the day. Our esteemed speaker, Dr. S.B. Hegre, who is professor at Pennsylvania State University, USA. Our panelists, Dr. Anuj Maheshwari, Vice President, Concrete Structures and Architecture, Reliance Industries Limited, and Engineer Ashwin Monge, Senior Vice President, Head, Technical Services, Key Accounts Cell, Ultratech Cement Limited. Our moderator, Dr. Bishwajit Bhattacharjee, Emeritus Professor at IIT New Delhi and also Advisory Editor of CE and CR. Before we start with our session, we would like to introduce to you CE and CR and Revert Media through a brief video presentation.
Civil Engineering and Construction Review, a leading infrastructure monthly on methods, materials, and machinery. Celebrating 34 years of publication. CE and CR is India's #1 infrastructure monthly news journal for the past 34 years. We have been providing discerning knowledge and an unmatched coverage of the construction sector since 1988. Get social with the largest online construction media network of India. Civil Engineering and Construction Review provides a valuable, informative, unmatched high-quality content. It is the most circulated magazine in India, having a readership over 17 countries worldwide. Google ranked #1 under the search of Civil Engineering Magazine India and Construction Magazine India. We have a 5-star rating as well. Currently stands at 58,000 plus followers on Facebook. 16,500 plus industry professionals connected on LinkedIn. You can also find us on other social media platforms such as Twitter, YouTube, Instagram, and SoundCloud. No one around us in India. CE and CR has been awarded the prestigious Best News Magazine by CIDC in the year 2014 and 2019. Best Publication Award by the ACCEI in 1991. Designated for International Quality Summit Award in Gold category in Paris by BID in the year 2012. We cover topics such as roads and pavements, bridges, construction equipment, concreting, precast, high-rise structures, waterproofing, and many more. CE and CR is read by construction companies, contractors, builders, government departments, public sector undertakings, building material and equipment manufacturers, consultant and architectural engineers, research institutes, polytechnics and colleges. Connect with the most circulated and trusted magazine in India.
Introducing Revered Media, a 360 degrees logistic solutions of business events. Who we are and what we do. Revered Media is an independent, full-service, professional logistics solutions company for business events. We specialize in corporate events with end-to-end event project management. Our commitment is to see each event through from the start to finish, while keeping the goals, vision, budget, and our clients' needs in mind at all times. We manage your events from conceptualization to execution, saving you the long hours, late nights, and endless emails so that you can focus on what's essential to you. We represent leading international exhibition organizers for promotion of their shows in India as well. Our unique selling proposition are: we have a focused and contemporary approach, wide contacts, rich experience in conceiving and managing high-profile events, working within deadlines and budget with maximum mileage and strong marketing instincts. We specialize in various types of events such as webinars, seminars, conferences, exhibitions, social media marketing, EDMs and e-newsletters, workshops, promotional advertisement and designing, public relations, product launch, award ceremonies, road shows, and many more. Our vision includes growth, innovation, affordability, and quality services. Contact us and join hands with Revered Media.
As we begin with the session, we would like to introduce our moderator to you all.
Dr. Bishwajit Bhattacharjee is an emeritus professor at the Department of Civil Engineering at IIT Delhi and an adjunct professor at IIT Jodhpur. He is a nominated fellow of Indian Association of Structural Engineers and a member of several professional bodies such as ICI. He was involved with academic activities with several international institutions, namely EPFL Switzerland, University of Dundee, UK, University of Dresden, Germany, and Catholic University at Leuven, Belgium. Dr. Bhattacharjee has supervised 200 MTech and 30 PhD theses till date and is currently guiding 2 ongoing PhD research projects. He has published more than 180 papers in various journals and conferences. He is active in several national committees involving DST, CBRI, NCCBM, Dr. Fixit Laboratory, BIS, and many more. A bio sketch of Professor Bhattacharjee titled A Teacher and a Research Worker under the feature People is available in August 2012 issue of ICJ and also under the title Gems of Structural Engineering in Structural Engineering Forum of India. Dr. Bhattacharjee is a recipient of ICI Lifetime Achievement Award, North in 2012. We welcome you, sir. Over to you.
Thank you very much. Thanks, CCR, for this, this inviting me as moderator. I'm privileged. I feel I'm privileged. And I have been given the responsibility of introducing the speaker and then the panelist. So good evening, everybody. It's actually great pleasure that I'm introducing Dr. S.B. Hegde, Professor, Pennsylvania State University. Dr. Hegde has got his PhD degree, doctorate. More than 30 years of experience he has got in cement, both in India and overseas. Currently, he is working as a visiting professor at Pennsylvania State University, USA, since January 2021. During his tenure in the current industry, in the cement industry, he has occupied the top level position as President Manufacturing and Group of Quality and R&D, Director of Group of Quality, a group director basically, Quality and R&D, and is a reputed in reputed major cement companies in India and of course overseas. Dr. Hegde is an expert panel member on Cement and Concrete Research Journal, Elsevier Publication USA, World Cement in UK, and has published more than 145 research papers in national and international journals. He has 6 patents to his credit and has successfully co-guided, guided, basically involved in guiding two students for obtaining PhD degree. Dr. Hegde is winner of Global Visionary Award instituted by Gujarat Chamber of Commerce and Industry and World Vision Ahmedabad in the year 2020. So we have a very esteemed personality speaking today, and we have very renowned panelists with us today, two of them. One is Dr. Anuj Maheshwari, a good friend of mine. He happened to have, I know him for many years. He happened to have taken one or two courses of mine and did, of course, extremely well. Never, not, worth mentioning that he is an excellent student, graduated from IIT Kanpur, even if without looking at anything, I can say, did his master's with Professor Skoshik at University of Engineering University of Roorkee, and then got his PhD degree at IIT Delhi. Currently, he is affiliated with Reliance Industry Limited as Vice President Engineering, CSA for Concrete Management. He started his career as a lecturer in civil engineering at Kota Engineering College, Rajasthan. Of course, where now the Rajasthan Technical University is also being housed, I believe. He has worked with various institutions such as Unitech Prefab, ACC Concrete, Ashoka Buildcon Limited, and Ultratech Cement Limited. Dr. Maheshwari's research interests are concrete, self-compacting concrete, high-performance concrete, high-strength concrete, high-volume fly ash concrete, SFRC, right, steel fiber reinforced concrete, that is, use of alternate materials for concretes, etc., and sustainability in concrete, durability of concrete, waterproofing, repair and rehabilitation of concrete structures. And if I may say so, he is almost involved in everything under the sun in the realm of concrete technology. One of the most experienced ready-mix concrete professional working since 1995 and got experience in every aspect of RMC business. Well, just to add that actually one of my students who did some work on RMC, he helped me in providing all the data way back in 2003 or 4, around that time. So it's actually, again, we are highly lucky that he is there in our panel. And I have a similarly esteemed member, panelist, is engineer Asin Moge. I happen to know him also for many years, possibly somewhere around 2003-4, if not more. 2003-4 is for sure, because it's the time when I visited his office in Mumbai, Andheri, and obviously we had good connections since then, right? So he is a postgraduate in civil engineering from BITS, Pilani, and presently working as Senior Vice President and Head Technical Services, Key Accounts Cell of Ultratech Cement Limited, that is, Technical Services is the one. And his wide experience is more than 27 years in the field of construction, cement and concrete technology, quality system, quality control, techniques and technical training of manpower. He's an active member of various professional organizations such as ICI, India, and India chapter of ACI, active member of organizing committee of various events and seminars of India chapter of American Concrete Institute, Indian Concrete Institute, Institution of Engineers, Cement Manufacturers Association, and many more. He is also a member of BIS committee, member of Board of Studies for updating curriculum of diploma, graduate and postgraduate courses of civil engineering, VGTI Mumbai and College of Engineering Pune. He is the past chairman and secretary of ICI Mumbai Center. So we have obviously all three great personalities, two panelists, and one the speaker. And we are, we are thankful to all of them. And I think now it goes to the organizers again for requesting the speaker to, uh, for presentation. I mean, on the behalf of the organizer, I'm already inviting Dr. Hegre for making his presentation, for which all of us are waiting. Dr. Hegre, please, and organizers will take care of the sharing and all that.
Thank you. Thank you, sir. I think my screen is visible, right?
Not yet, sir.
Not yet. I have to share the screen.
Yes, sir.
Okay. Visible now?
Yes.
Yes, sir.
But not in slideshow mode.
It's in slide sorter. Make it in presentation mode, please.
Yeah. Put it in slideshow mode, it will come.
It is slideshow. I think it is in the slideshow mode only, right? Can you confirm it is in the slideshow mode?
No, it is not.
No,
It is not. It is not.
it's slide sorter.
It's showing home.
But in my this thing
Yeah.
is showing full.
Dr. Hegde, once you unshare and share, perhaps sometimes it
Yeah. Share the full screen.
Yeah.
And
make it
Stop sharing. Okay.
stop sharing, make it on a full presentation mode, and then share this.
I'm doing that.
Yeah.
yes,
Now it's
Okay.
done.
Yes, sir. It's visible now.
Okay. Good evening, respected Bhattacharya, Ashwin Mugeji, Dr. Anuj Maheshwari, Praveer Bhattacharya, and all the organizers of CE and CR, and all attendees who are attending this webinar. So this is a very big topic, very researched topic, very hot topic, evergreen topic. So I will definitely try my level best to do the justice to this topic. As you all aware that if you see the durability, the definition of durability, what Dr. Neville says, it means that the given concrete structure continue to perform its intended functions, that is to maintain its required strength and serviceability during the specified or traditionally expected service life. So as you are all aware that the topic is very wide, and it is quite relevant even today and in the future also, to see the different, the agents it is hampering the durability of concrete. So let us see one by one. I will start with some of the facts about the durability and all you may be aware. But for the sake of the attendees, I will just go through these slides, which are very basic in nature. So let us consider these factors, what are the factors affect the durability of concrete. If you see that the main component is the materials used in the manufacture of concrete, the method of manufacture, placing, compacting, curing, environmental conditions, long patterns, various pollutants like carbon dioxide, chemicals that have pervaded the environment. So according to as per IS 456, the durable concrete is one that performs satisfactorily in the working conditions, working environment during the anticipated exposure conditions and during its service life. Also, durability is also affected by the The things like, the water ingress of water, oxygen content, carbon dioxide, chloride, sulfate, and other potentially deleterious substances. The impermeability is greatly governed because this is what is required. If the concrete is not impermeable, if it is pervious, then obviously the deleterious components in the form of solutions of fluids enter into the concrete structure, and it will destroy the concrete. So therefore, the environment like rain, heat, cold, fire, snow, the cover to the embedded steel, type and quality of constraint material, cement content, all are very important factors affecting the durability. And if you see the different agents, which is hampering the durability of concrete, there are two things. One is external and one other is internal. So external, if you see, there are the physical things like which I mentioned earlier is the freezing and thawing, percolation and permeability, and chemical is the alkali aggregate reaction, sulfate attack, chloride ingress, delayed attringite formation, corrosion of reinforcement, etc. And also certain things are happening, the volume changes. Physically, it is happening due to different thermal properties of aggregates and cement paste, frost action, etc. The volume expansion is exerting a lot of pressure on the structure of the concrete, and it will show crack. It will start showing cracks. And chemical, as I mentioned, is alkali silicate reaction, alkali carbonate reaction, etc. And if you see the environmental conditions responsible for concrete durability is, there are 5 things. 5 environmental conditions have been mentioned: mild, moderate, severe, very severe, and extreme. The exposure conditions are shown in the slide, which you can see because of the I have to cover a lot of topic. I think you can see the slide and you can find out what are all the exposure conditions are prevailing at different environmental conditions. And if you see the general, when you are talking about the general design requirements, the shape or design details shall be such that proper drainage is provided, avoid standing pool of water, junctions of members properly designed. Second is the minimize cracks that will transmit water. Third one is proper compaction and curing. Fourth one is concrete is prone to deterioration due to climatic and chemical attack. Deterioration in sections under hydrostatic pressure from one side, and partially immersed sections at corners and edges of the elements. So these are certain, the design things have been considered. Second one is the stiffness factors. The span to effective depth ratios up to 10 m. For example, this cantilever beam 7, supply supported beams 20, continuous beam 26. For span above 10 meter, the ratios above shall be multiplied by 10 divided by span in meters. So what are all the factors responsible for strength of the concrete? If you see, the major things, as you are aware, that the water cement ratio plays a very important role. Then comes cement type, aggregate grading, shape, surface texture, proportions of materials, porosity, air entrainment, mixing of waters, admixtures, curing conditions, humidity, temperature, all will have a direct effect on the strength of the concrete. And to show, to give some idea about the strength of concrete, I have taken the example of M25 concrete. The permissible stresses are mentioned here. Compressive stress is 6 N by mm square direct. So various permissible stresses have been mentioned here: tensile stress, flexural stress, shear stress, bond stress. And the strength of concrete, what is the grade of concrete, and the bond stress N by mm square, everything has been mentioned. I don't want to read each and everything. I have given from M22 and M40 and above. You can see the bond stress N by mm square. And the acceptance criteria, if you see, standard deviation for M50 is 5 N mm square, M55 is 5 N mm square, and M60 is 5. And the acceptance criteria as I have shown from M10 to M35. And this is acceptance criteria of standard deviation of the strength of the concrete. You can see from the slide. And as I mentioned earlier, The strength of the concrete is also governed by the cement chemistry, because cement is one of the important components in the concrete. And these two photographs which I shown, one is on the left hand side of yours, is a very state of the art plant of the cement plant. You can see the plant is in operation, but absolutely crystal clear skies. So needless to say that there is no emission of dust in the atmosphere. And if you use another photograph is showing the micro photograph of a clinker, polished sample of a clinker, which shows the alite, belite, silicate and ferrite. These combination, these four phases are responsible for the effects in the cement. And this particular slide shows the composition of cement. As I mentioned earlier, four components are very important in cement. One is tricalcium silicate, dicalcium silicate, tricalcium aluminate, and fourth one is tetracalcium aluminate. And you know the function of this, all the four ingredients. For example, the C3S is responsible for early and later strength. Dicalcium is for responsible for later strength, and tricalcium aluminate is for also for to some extent initial strength, and also for setting the responsible for setting of the cement. And tetracalcium aluminoferrite does not impart any of the strength giving tendency, but it is like acting like a coloring agent. So another slide which I placed is the heat of hydration of these compounds. So from this slide you can see that C3S, the maximum amount of temperature is being emanated by C3A. So C3A is responsible, followed by C3S. So the heat of hydration can be reduced if you have, if you control the C3S percentage and C3A percentage by adding cementitious material. So just have this on the mind. And if you add water into the cement will start hydrating, and C3S will react with water. It forms CSH gel. Similarly, the C2S, and C3A also I will show in the next slide the reactions. The calcium hydroxide also is coming out of the hydration process, but it is very unstable and undesirable, because more the calcium hydroxide, it is just like high blood sugar if you compare the human body. So for cement, the high calcium hydroxide is just like diabetes. So this is the hydration reactions which I shown is that C3A reacts with water, it gives the entrained, and the C3A once again reacts with what is leftover entrained, it forms monosulfoaluminate, and C3S C2S is giving CSH gel, which is responsible for strength formation, strength generation, and this is the reaction of the hydration. In this slide, I have shown the different types of cement, which I am not going to discuss in detail because of the less time availability. So majorly the sulfate resistant cement, rapid hardening, low heat cement, and is available in India. And if you see the cements as per ASTM standard, there are 5 types of cement, which covers even OPC as well as the blended cement also. The codal provisions, if you look at it, the standard codes of all the construction practices is SP62, CPWD standard specifications, IS 456, NBC 2005. These are the codal is available for the reference. And if you see the another slide, the minimum cement content I have shown maximum water cement ratio for RCC for 4 different type of environmental conditions: mild, moderate, severe, extreme. What should be the cement content and what should be the water cement ratio for which grade of concrete? Everything has been shown. And type of cement which I mentioned in India, I think there is no only OPC 269 is available, and then PPC IS 1489, sulfate resisting cement, rapid hardening cement, even though PSC, everything is available. But there is no such category like 43, 33 or 53 that has been clubbed to IS 269. And this is a specification for the IS for the admixtures. So you can see the different type of admixtures for retardation and for reduction of the waters. So depending upon the water reduction, it is classed as plasticizers and super plasticizers. And also in the admixtures, the air entering admixture or air entering agents are coming, which is very, very important thing. These they will improve the durability, water tightness, and workability, etc. So it's very important. And if you see the another table, the slump, what should be the slump? If you in the different placing conditions, the blinding concrete, shallow sections, mass concreting, heavy reinforces, thick form work, etc. And the degree of workability is also mentioned. And what should be the slump compacting factor, that also has been mentioned in this table. And second, then we will go to the chemical action on concrete. If you see, look at this table, there are concentration of different concentration of SO3 are available at 5 different situations, and the required minimum cement content has been mentioned with maximum water cement ratio, and what type of cement are to be used are also have been tabulated, and you can see by yourself. And another table talks about the chloride content, the concrete, the type of concrete, and the maximum chloride per kg per cubic meter has been shown here. And similarly, the water used in the concrete for organic, inorganic sulfates and chloride PCC, the permeability limit as per IS has been mentioned for your reference. What should be the permissible limit of water? And the next important thing is the durability is also governed by the soils and water, because majority of some of the soils which contain sulfates and other deleterious components which is directly come in contact with the concrete and responsible for sulfate attack, which goes into the structure of the concrete, and the sulfate attack will be started. And the magnesium oxide is also very much very, very important for durability of the concrete, just like sulfate attack. The magnesium sulfate, which I mentioned, magnesium sulfate reacts not only with calcium hydroxide and hydrated calcium aluminates, but also decomposes hydrated calcium silicates completely. So you can see the white patches, if it is, you can observe from that, if it is attacked by the magnesium sulfates. So how to control this sulfate attack? The use of sulfate resisting cement with low C3A content is one option. Then quality of the concrete should be good. You have to use the air entraining agents and use pozzolanic materials or cementitious materials. These are certain options are available for making it durable. The structure, because the water also contains a lot of TDS. If TDS is very high, once the water is evaporated, there will be an incrustation of the salts, and which is responsible for the disintegration or the durability of the concrete in doldrum. So here just I wanted to show, because you have to have some idea about the relationship between the CO2 emission and clinker phases. Because why I'm started this topic is, nowadays the sustainability and the durability are the two faces of the same coin, and both of the things should go hand in hand. That is what is the requirement now. So just to give an idea to the benefit of the attendees, so I have mentioned first sentence, if you see the C4AF, C2S, C3S, C3S, C2S and C3S. So the carbon emission level is getting reduced from C3S2 towards C4AF. That means, needless to say, that we need to have the C3S content in the moderate level, or you have to have a low clinker percentage in the cement. We will discuss in the coming slides. So now we are talking about the durability to enhance concrete stability, because this is the route. This is how we have to go. It should go hand in hand, because we cannot do the work only on sustainability or only on durability, and both the things are to be looked into, and we cannot do it in isolation. As you all know that the sustainability of concrete buildings and infrastructure must be considered, both in terms of its benefit to society and the environment, impact associated with its use in construction. So as you are aware that the concrete is very cheap material, and therefore it has gained a lot of importance in the construction. Similarly, the durability performance of construction materials is important. The concrete is often considered to be inherently durable due to chemical and physical resistance to various environments and dimensional stability. And of late, the cement, the concrete making also incorporating a lot of waste material into the system to talk about the sustainability initiatives or the circular concept, circular economy. The waste utilization, as I mentioned, it is started now. For example, waste oils and other combustible materials. We started because cement and concrete are going in hand, because cement is not the end product. The end product is the concrete. So what is required is how much CO2 is coming out from cement making or concrete is important. Therefore, it is very, very important to use so much of sustainability initiatives in the cement plants. And cement plants is using a lot of the various alternate fuels, the wastes from the municipality, and plastics, tires, etc., etc. So similarly, the things have been started in concrete making also. That I will show discuss in the next slide. So some of the, if you see this table, the durability characteristics of concrete constants are mentioned. Component of concrete is hardened cement concrete, force structure, aggregate, reinforcing, and this is the characteristics of this material. And what is the effect of that in the enhancement of durability? Also, you can see from this table. So this particular slide shows how to mitigate the concrete deterioration in order to attain the sustainable approach. So various deterioration things are happening. For example, the corrosion of rebar, alkali silica reaction, physical attack and abrasion, sewer pipe corrosion, etc. The three options which I mentioned here is the improved cover resistance using SCM, use of SCM such as fly ash, correct concrete strength and curing. Then option 2, increasing cover depth of reinforcing, use non-reactive aggregates, good finishing of concrete surface. Option 3 is increasing cement content of concrete, use of low alkali cements, surface hardeners and penetrants, etc. So now we are talking about the improved service life. So as you are all aware that the buildings or the structures have been designed for 30 to 50 years. So if you can double the service life of structures, maybe 100 to 50 to 100 years, does not require a significant increase in construction resources. In many cases, the extra requirement involves only a slight adjustment in the concrete resistance or cover depth to the embedded concrete. By this thing, we can improve the service life of the concrete, of the structure. The cover concrete that surrounds the reinforcing steel provides protection from environmental agents such as moisture and salt that cause corrosion. One example I given, this is a bridge in New Zealand, and the table shows that PC percentage has been mentioned from 900 to 50%, then SCM percentage, then 40 mm cover and 60 mm cover. You can see the effect of this. Then the greater utilization of wastes in the concrete, which I already mentioned. And if you see this slide, Various materials have been used, the waste material like recycled concrete, crushed glass, crumb rubber, latex paint, etc., etc. But you can see the effect of that. The durability consideration, more viable, possible contamination, increased shrinkage. So the durability may increase or it may hamper also by using of this waste material, that we have to take it in mind and make a sort of optimization, what should be the level of addition of these materials, so that the durability also should not be hampered. At the same time, these materials are also being used, so we have to have a balance of that. So next point is the improved structural performance is obviously a very important thing to improve the service life of the concrete, which I already mentioned. And some examples of recent innovation which I included, like reactive powder concrete with extremely high strength, high ductility engineered cementitious composites, lightweight concrete with enhanced structural performance, photocatalytic cement for self-cleaning concrete surfaces, etc. So for better construction, I think now the new type of concretes have come out. I think like self-compacting concrete, fiber reinforced concrete, etc. have been come into the picture, or we can say some special concretes. So in this table, you can see the self-compacting concrete, fiber reinforced concrete, controlled permeability formwork. What is the construction benefits out of it, and material benefit? What is the advantage of using this type of concrete? Also have been mentioned. So this particular table shows the various new generation concretes, or we can say it is a special concrete. You can see from this table that where it is being used and what is the composition of this concrete, what are the ingredients, etc. have been detailedly mentioned. And I have tabulated around 10 special concretes that you can see from this table. Then next important is the creating durable green concrete solutions. So as I mentioned earlier, the wastes are to be used, because when we are talking about the circular economy in cement company or cement plant, so that also will hold good in the concrete making. Some of the examples of the durable and green solutions for concrete include improving the bonding between paste and crumb rubber using magnesia cements, reducing shrinkage of recycled aggregate concrete using fly ash and slag additions, using SCM to prevent ASR expansion of concrete containing waste classes. In fact, I would like to mention here that we have taken as a project on waste glass as a pozzolana in Penn State University for MS students. So now it is a very important thing, how to ensure the durability is very important thing. So various things have been I mentioned here. Because of the lack of time, I don't want to discuss. You can see it from the slide. The script is prescriptive or recipe type. Sometimes the specifications are the hurdles, like prescriptive specifications. So what are all the limitations? What are all the hurdles in it? Everything I have mentioned here in the durability, ensuring durability slide. Then advantages of performance-based specifications, because most of the countries are going towards this performance-based specifications. In India, we have been talking only, but nothing is concretely being done. So with the performance-based specification, these are the advantages. Concrete is more efficient since materials processing can be optimized. Durability potential can be predicted at construction, allowing early remedial work. Durability performance is enhanced since this is implicit rather than inferred. Reduces the inherent conservatism in larger infrastructure projects, etc. So in this particular slide, if you see the table there, you can see the durability performance test for concrete: chloride, carbonation resistance, water absorption, etc., etc. and what are all the measured parameters, and what is the intended benefits for it. That also have been mentioned in this table. And I have put forth some thoughts on the future outlook of the concrete durability. If you see the number 1 point, the philosophy of high strength and concrete, is it durable and sustainable? So as I mentioned here, the world is passing through difficult and troubled times as we live in a rapidly changing world. The construction industry is facing many challenges: global warming, climate change factors, and the capability to achieve sustainable development and economic progress without damaging our environment. So is it this is a misleading concept? I'm just asking a question. Asking for high initial strength in cement, high strength concrete, that is primarily responsible for the lack of durable performance of concrete in real life environments. If this is so, to change this scenario, it is suggested that the concrete must be manufactured for durability, not for strength. So these are some of my ideas I have put forward, put before you for this deliberation. And the philosophy of holistic durability design policy philosophy. What is this? Is an integrated material and structural design strategy of strength through durability are the need of the hour rather than for strength, and structures are designed for ductility and structural integrity. The holistic design envisages a global approach to all aspects of concrete and construction technology, from material selection, design, construction, and maintenance to service life, integrating material characteristics with in situ performance. Use of cement replacement materials, design of material stability, design of structural integrity, and design for sustainability are the key elements of this holistic durability design to achieve durable service life performance. So second, which I mentioned, is the training of construction workers. I don't want to dwell upon that. This is the need of the hour. I think CIDC is doing good work in other parts of India, but what I meant to say is that some sort of the academic degrees or diplomas can be this can be taught for the skill development program. I think if you go to the websites of skill development of the government of India or any state governments, you can see one department for the skill development, and there are various courses have been mentioned in that. So we have to take the advantage of that. Third one is the performance-based approach of our concrete durability, which I already mentioned. Then performance-based approach will continue, like for example, the prescriptive requirements, etc., which I already mentioned, like cover zone, etc. What is the advantage of performance-based design specifications have been mentioned. There are some shortcomings of if you focus on the characteristic of raw material mix proportion, batch mixing, transport of fresh concrete, and range of construction operation from placing to curing. We have to focus on that very keenly. Performance-based durability design concepts are based on quantitative predictions for durability or service life from prevailing exposure conditions and measured material parameters. In many countries, the performance approaches are still mostly in the research stage, have so far found limited or practical application. Then this is about the futuristic thing for future research and development needs, which I mentioned here is how one is you can see, for example, the second point is suitable approach for all stages from initial mix design process to quality control and conformity assessment of in situ concrete has been restricted to individual countries in South Africa and Switzerland, showing the most advanced progress at this stage. And third one is where is a game changer, that is more research on commercialization is needed for carbon negative concrete is the need of the hour and would be game changer for the sustainable future. So when come to conclusion, the need for reliable performance approaches relates to shortcomings of the traditionally prescriptive design methods for concrete durability. These methods, which are usually based on selecting limited combination of mixed parameters for a range of environmental exposure conditions, largely fail to account for the influence of constrained materials cannot account for influence of construction procedures. There is no doubt that over the past 2 decades, we have made enormous advances in the understanding and practice of concrete durability. The durability design is a beginning to be considered for equal importance as design for safety and serviceability. Nevertheless, durability concerns remain, and early deterioration still attracts much expenditure. Based on current design practice and current knowledge, future research and development needs would be an influence of the constraint materials, deterioration prevention methods, service life modeling of reinforced concrete structures, and performance-based test methods. The key durability challenges lies in predicting the performance of new materials, where the increasing diversity of the cement and concrete plays a major role. As most current engineering models are not capable of predicting actual field performance adequately, a knowledge-based approach to durability will become more important than ever. Only a scientific approach on a multi-scale, interdisciplinary level will allow predicting performance of new materials. This will facilitate the use of more performance-based durability design that is urgently needed to promote innovative, long-lasting solutions. So thank you very much for the patient hearing. Thank you. Over to the organizers.
Thank you very much. Thank you very much for a very elaborate lecture, but I must say that you have actually adhered to the time, and that's quite often we find that that's actually violated, but you have exactly finished at 5.
Okay, thank you.
So we have plenty of time for question answer sessions, and the panelists are invited now, and if the audience have questions, we would like to first react to that, and then of course I'll request the panelists to give their own comments if any. But first let's have some question answer session. So it is open for questions now to the audience. How will they do? I mean, they can write, of course, in the chat box, but you can directly ask them also, I suppose.
I think there is chat box.
I think there's certain questions in the question box as well.
Yeah, that's the chat box. They will do that. But if there is, let me see, I didn't see any so far. But even they can speak if it is allowed.
So there are 16 questions in the Q&A section.
Okay, so where do I get them?
So there's a Q&A section
just beside the participants.
Sir, may I take your permission to put forth one of the suggestions?
Yeah, please go ahead.
So there are here, I have been seeing this question. I think if you permit us, my suggestion is that some of the questions and our very knowledgeable panelists can answer such questions along with me.
Sure,
so please permit me and permit them to ask because it's a value addition anyway.
Yeah, obviously the question should be answered by all. So, but the question is, where is I'm trying to figure out the questions. Where did I see them?
This is under question and answer.
Yeah, I got it. 19 questions are there.
Right.
Yeah. So the questions, first question I could see is one of them is from, yes, many of them in fact. Yes, one is from Dada Patil. How much is RCPT reliable? So it can come from all. So maybe speaker has already spoken for quite a lot of time. So we start from Anuj, go to Dr. Mr. Mahesh Moge, and then speaker, and then I'll also chip it.
Sure. Reliability of RCPT, is that depends on the cementitious system that we are using per se. But if we are talking about the values per se, this RCPT values are, let's say, classified into 5 categories, ranging from high, moderate, low, very low, and negligible. If the question is towards the values, then it varies from 4,000 coulombs to less than 100 under the various, let's say, categories. So also RCPT values are highly sensitive to the type of cementitious matrix that we are using. That means along with OPC, what type of supplementary cementitious material that is being used. Per se, it does have an impact. So for a particular cementitious system, RCPT value can only indicate the relative, let's say, resistance of that particular cementitious system to the chloride. Let's say charge passed because of the chloride ions.
Yes.
Yeah. So further to add what Dr. Anup has said, that RCPT value is measured in coulomb, and the sample what you are taking it has to be a truly representative sample of what it is going in the structure. And that's why you can correlate with that, right? Because that should be the part of that, so that it will reflect into that when we are predicting the life of the structure, or basically the designer takes into consideration various attack mechanisms. So RCPT value is reliable. Along with that, certainly for high performance concrete, people also add water penetration test. And recently there is another test which has been added into that, is RCMT, rapid chloride migration test. So these will define, normally durability is measured in terms of that. Only RCPT values may not suffice to the requirement, but yes, that is water penetration test, and now the new test which is being used, that RCMT test also can work on towards the durability part. Yeah.
Yes, Dr. Hegde, would you like to add something?
No, it's okay, sir. They have covered it.
Well, I do have I think reliability is not the question. The question is, what are you looking for? This is a qualitative measure, please understand. You are trying to see chloride ion migration, as I call it, because it's not diffusion process, under electric field. In nature, electric field doesn't exist. Therefore, it only tells you how much electric charge will move, rather how much charge is required to move the chloride from one side to the other. So it's a qualitative relative measure. Qualitative, do not try to link it to service life or anything of that kind, or chloride diffusion coefficient. And what Dr. Maheshwari says is very important. If you put, it depends upon resistivity of the concrete strongly, because you are applying electric field. And if the resistance of the concrete, which increases due to pozzolanic addition, you will always get better results. So that's where our CBT lies. I, for one, wouldn't say that you should do it in Delhi. If you want to do it in anywhere, then do it in Mumbai or Chennai. Such a test for durability should not be generalized for durability, but it tells you under electric field how much chloride can move, which is not a natural process. All right. So, this is, adopted by Estato Americans and, because they had, remember, there's one difference with the Europe and North America. They have de-icing salts, which is a major cause of chloride ingress. And in India, it is not so. We don't have de-icing salts. We have marine environment, that's all. So, that's it. That's my comments, sir. I suppose anything else anybody would like to say on this?
So
Or
there are
else we
few
move to-
participants who has raised their hands.
Yeah.
If you allows, then we'll ask them.
Yeah, because we have time. We have plenty of time, I was told. So
Okay.
they want to ask a question, right? Then we'll go to
Yes.
the written question next.
Just a
after.
minute, sir. So we have with us Mr. Murari Ratnam.
Oh yes, Dr. Murari Ratnam. How are you? Good evening.
He's mute. I think he's mute.
Yeah, you can unmute and you can.
We will request Dr. Ratnam to unmute him.
Yeah, I have unmuted.
Thank you, sir.
Yeah, it's my turn.
Yes.
Okay. It's a very interesting lecture. Myself, having worked in the field of durability of concrete for donkey number of years, and in this field and handled various hydropower projects. And it's a very interesting subject area. And Dr. Hegde has given us a very good insight. And I know Professor Bhattacharya has been a pioneer in this field also. Any further development in the field of alkali aggregate reaction, any other apart from what you have quoted from IS 456? Anybody can throw light? Because I've been out of this subject for last 6 years. Okay, it's all right.
I have not come across much on this. The reason is that, it's not a very common problem everywhere. Unlike the rework.
It's only probably, it's not in small and medium structures. It's in the large structures. I agree. And wherever there is moisture.
No,
Anyway,
not only that, not only that, it is actually also, there in those places where concrete has never been constructed. You are trying to use a new aggregate.
Yeah.
So in Delhi, quartzite has been used for many years and never shown any kind of alkali aggregate reactivity. And therefore, people are using it and not finding it much.
It's not, as I said, it's not a problem in the small and medium structures. It's only
in dams.
Where basically the reaction takes place if there is moisture around, and that can happen only in the dams.
No, moisture happens in even bridge. Even I have come across one of the alkali aggregate
bridge is another area. Bridge is another area.
Yeah. But that's not because of the moisture. The aggregates they have used untested. Damn, nobody will allow you to use untested aggregate. You'll never, everybody go to NC, what you call CSMRS to test first.
Yeah, but basically the expansive forces are set in by the moisture.
That's true. Otherwise, gel formation will not occur.
Gel formation will not happen.
And it depends also on the, the mineralogy of the aggregate.
Yeah, that reactive.
Yeah, of course.
Yeah,
I mean, you have to have
that we are all aware.
Yeah, opal, chalcedony, etc. It's all done, and that's what they do petrography test.
The petrography test.
Yes. So many important projects. Like suppose I will take an example: nuclear power corporation. When nuclear reactor is being constructed, it's one of the very important structure and one of the safe structure in the country. So there they do petrographic stress. Although because reactive silica from the past experience, people will come to know. But other important projects, like suppose, for example, bullet train project or any other important project, say nuclear power, they go for petrography test and then they find it out the aggregate in advance and they conduct the test because it takes a lot of time also. So now because of petrographic test, it is becoming, you can predict it earlier. Otherwise, earlier it used to take a lot of time. But now it is they are testing it because the different quarries, even if they will change the quarry source for important project I'm talking about. So they do the test and then only they allow the source for using it.
That's very interesting point. Because they're a high-end project like bullet train and other things. Definitely any precautionary test is always a preferable one.
Yes.
Just to share the practices followed in ready-mix concrete, let's say business. So we go for establishing this petrographic analysis of aggregates for every new query that we will get into. And that is a mandatory, let's say, with a protocol to be followed. Even if we are doing concrete for the normal, let's say, with structures and just like the residential one or the commercial ones.
That's good to hear.
But then there are, cases are not that many.
Cases are not that many. I agree.
Except for the aggregates found in the Shivalik belt or let's say
northeast.
Right.
No. The Himalayan belt is the Himalayan belt is the real where all these investigations are very important.
Yes.
I'm talking from the hydropower dam project.
Absolutely.
And more often than not, we end up in a reactive aggregate, and then this fly ash based and 0.6.
Yes.
Rules come.
Alkali. Yes.
Alkali aggregate. 0.6.
Low Low alkali
low
cement.
alkali cement.
Right. So
So
equivalent sodium oxide will be equivalent. Anyway,
Yeah,
let's
equivalent
go to,
sodium oxide.
yeah. So we'll go to one more question from the written one, which is sent at 4:32 p.m. And then again we'll go people who are raising hand.
Yeah.
So Kalidas Nateri, who has put in a question: the durability governed not only by the cement but by cementitial material that include complementary cement materials. Well, what is the question? Question is not there. It is.
I think this is a
I think he
comment.
covered it. Yeah, there's a comment, and so we'll not really need not respond, because I think in the lecture he's talked about something related to all this. So can we go to the hand raised by somebody?
Yes, sir. Just a minute. Now we have Mr. Kanta Rao with us.
Oh, good friend. Again, good friend of mine.
Hello, sir. Am I audible?
Yeah.
Yes, you are audible. Very much.
Good evening, Dr. Hegde. Good evening, Professor.
Good evening. Good evening, sir.
Both are my good friends. Nice lecture, sir, Professor Dr. Hegde, sir.
Thank you, sir.
Just one small question. You spoke about reactive powder concrete. Nowadays, it's called ultra high performance concrete. Actually, it contains very high quantities of cement, up to 700, 750 kg per cubic meter. Is it really good for from carbon emission point of view to use UHPC? Because the world is crying about carbon dioxide emissions and all. So, are we doing good to the society by using UHPC? That's my question. First question, sir.
I think Bhattacharya Saab can throw light on that.
Yes, actually, you see, if you look at the dimension of that RHPC, ultra high performance concrete, it is smaller than steel. It is comparable to steel, because if you have grade 250, which is used as structural grade, 800 is of course used for substrate of electronics and things like that, higher grade. But 250 grade, just imagine you have something 250 MPa compressive strength. Freeze test it.
Yeah.
You are getting equivalent tensile strength as well.
Yeah.
So section becomes much smaller.
Okay.
Very small.
Yes, and therefore the carbon issue has to be looked into holistically, rather than 700 kg cement, all right, but if you make the size very low, it has to be looked into from that point of view. But then remember, you are using large quantity of silica fume there also.
Yes.
Not only the ordinary Portland cement,
steel fibers also.
Steel fibers.
Yes.
Yes.
Steel fibers. Yeah, that's for pseudoductility.
Yeah.
Obviously pre-stressing. Yes.
Sir, one more question, sir. In one of your slides, you showed for the sulfate attack, heat curing of heat treatment of concrete. You actually it has come actually, but does it not actually affect DEF, delayed ingot formation? Does it lead to it has come in one of your slides actually as a last point to control the sulfate attack?
Yes. Sometimes.
Okay. Thank you, sir. Thank you so much.
Yeah, and to add what Dr. Bhattacharya has said, see, when you are going for UHPC, you are not going for all the structure UHPC, right? So only where the desired strength is required and you can eliminate, or you have a long spans, especially for that.
Correct.
Another thing is the life is enhanced. See, again, what is meant by sustainability? You can enhance the life. So suppose the life of the bridge is say 60 years, and because of this UHPC, if we are going to make it 120 years, so certainly it is going to become a sustainable again, because sustainability is again enhancing the life. So that way also it helps. So as in terms of only looking at it from the carbon footprint point of view, that here it may require 450 and there you may require 800 kg. So that we'll have to see, as Dr. Bhattacharya has said, holistically we'll have to see it in the complete life cycle analysis of the structure.
Thank you, sir. Thank you so much.
Thank you.
Okay, so we'll go to Dada Patil. We have actually answered his question earlier. He had another question. That is, we'll take it up later on maybe. How permissible stresses related to working stress method. However, we design most of the structure in limits to your comments on this. Well, I think we have answered one of your questions. So let's go to Mr. Bhaskar Agate. Would you please throw some light on self-healing concrete and durability? That's the question. So anyone would like to react to that? Self-healing concrete and
Yes,
durability.
self-healing concrete. Oh, okay, I'll try to just address it out. So self-healing concrete, let's say we have different approaches to it. Some of the researchers are doing their work with respect to the bacterial concrete, where this calcium carbonates are being formed because of the bacterial activity.
Correct.
And the basic purpose of this particular self-healing concrete is to, let's say, bridge up whatever cracks are being formed because of the serviceability of the structures. So these cracks are healed inherently by the components that have been used in the manufacture of the concrete. Another approach happens to be on the crystal formation. So the certain chemicals are being used which forms crystal whenever the water ingress is there in the crevices. So the amount of space is required and the amount of water ingress is required before such type of crystalline structures are formed. And ultimately, finally, they can bridge up all the cracks. Yes, if the cracks are bridged up, the durability will definitely be enhanced. And I think this is one of the areas that has to be looked very carefully and very, let's say, intensely. It has a huge potential to for the sustainability of the concrete as well as the durability.
His second question is, which laboratories are working on developing self-healing concrete in India? I can just add what I know, others can add more. You see, Jadavpur University was working, Thapar University in Patiala was working when their biochemical department, then Bengal Engineering College was working, and VGTI was also working once upon a time. I think, you know, one PhD, which I actually examined of Abhijit Mukherjee student in VGTI. So he has been working. I don't know whether they're continuing to work with that right now. Bacterial concrete.
Yes. Yes. Yes, sir. IIT Bombay also has done working on that.
Yeah, that's what I say. No, Abhijit Mukherjee
Yes.
and his student from VGTI.
Yes. Yeah. Dr. Sarode has done his PhD.
Dr. Sarode. And good lot of work with the even silica, you know, calcium, like as Dr. Maheshwari said, that it is calcium hydroxide, which is eaten away by bacteria to convert into calcium carbonate, like in coral. Jadavpur University has developed something where they have isolated a bacteria which can act on silica and convert it into a silicate system, solid. And these are research at the moment.
Yes.
Okay, so anybody raising hand and their question we can take. Dr. Rajmana has got a lot of comment. We'll come to him sometime.
So next we have Mr. Nishit with us.
Yeah, hello, good evening. Am I audible?
Yes, partially, not fully.
Yeah.
You can come close to the mic.
Yeah, I'm now very much close to mic. I hope I'm
not audible.
It's audible now, sir.
So, sir, I am working in Central Soil and Material Research Station as a concrete scientist. And my question related to the durability and sustainability of concrete is, we are conducting many investigations like rapid chloride permeability test, and water impermeability tests like DIN, with reference to DIN. So what are the other investigations that we can perform to assess the long-term durability of concrete? That is my first question. And as far as the sustainability is concerned, we are talking too much on the production of concrete cement to reduce the carbon footprint. But nobody is talking about the production of steel, bricks, and other construction materials that are also having equal contribution in the production of carbon. So we should we focus on that part also?
So if I understand your question correctly, because audibility was problem, you're saying that everybody, as far as carbon emission is concerned, everybody is concerned about cement and concrete. Not why not steel and brick? Am I right?
Right, sir. Right, sir.
Yeah. So anybody would like to answer? Actually, if you look at the anthropogenic carbon dioxide generation, the first is fossil fuel. Majority. 5 to 7% is attributed to, okay, let's say even now it will be less, because your clinker factor is reducing all over the world. People are using pozzolana, supplementary, complementary cementitious material, whatever you say. So it's around 5%. Next is the next candidate, comes from cement. Because calcium carbonate, you are calcining, so carbon dioxide you are producing. So, but more importantly, if you see the amount of cement you consume, it is next after, concrete you consume is next after water. So total quantity of cement that the human being use, in India, perhaps it used to be 200 kg per person or something like that.
Yes.
260.
Yeah.
Around 250, right?
Yeah, 250 now it has gone to. Yeah. And in that case, you see, just multiply and see how much out of this, if we take even 1 ton of cement, is not producing 1 ton of carbon dioxide, because efficiencies of cement plants have improved and they are not using alternate fuels are being used. But stoichiometric carbon dioxide, you can't do anything. So 0.5, 1 ton of cement will produce at least 0.55 tons of OPC, I'm talking of carbon dioxide. But your clinker factor is reduced. So whatever it is. So that's why cement has been given a what you call privileged position, but it's not so much really. But the quantum we use is so much, is that the volume of you use is very large. So you got to address this point. That's I think the issue.
Okay, sir. Thank you, sir. Sir, my first question was what type of investigation should be conducted in terms of long-term durability to assess the long-term durability of concrete structure?
Not clear. Can you repeat this question for the panelist?
I think Mattav, he's asking for the different type of tests that can be used to assess the durability part.
Oh.
Have I understood correctly?
Right, sir. Right,
yeah.
sir.
Yeah, let my
Nishit,
friend
I think there are many tests available depending on the type of transport mechanisms that normally, let's say, are responsible for the deterioration of the concrete structures. If we talk about the concrete structures, there are many ways the concrete can be deteriorated. Either the cementitious part, is affected, or the steel part is affected. With the steel, we normally refer to the corrosion of the steel, where chloride ingress or the carbonation are the main mechanisms. Based on the exposure conditions, whether it is a marine structure, whether it is the exposure to carbon dioxide is more, or subsoil exposures are quite high. Chemicals are quite high there. So based on the type of exposure, we need to understand what is going to be the transport mechanism, and have to select the type of test that we are going to understand or quantify the durability part. Coming to various tests, there are so many: oxygen permeability, gas permeability, RCPT, rapid chloride migration test, as Shwin has mentioned, sorptivity test as per ASTM C1885, 1585. So, the ultimate objective of any durability test is to quantify. Most of the tests are qualitative and only give the relative, let's say, performance of the concrete as a material in, let's say, resisting the ingress of the chemicals here. If we talk about rapid chloride penetration test, migration test, RCMT, and sorptivity. So these are two tests, very specific, but these can be translated in quantifying the design service life. in predicting the design service life based on the values that we get for the material. Sir.
Yes, anyone else would like to add?
Yeah, no, I think, okay. Okay, I think Anuj has covered it because it depends on the purpose for which it is and the transport mechanism which is prevailing there. Like suppose if it is in the marine environment structure, so certainly carbonation as well as chloride will be a more, we'll have to take consideration of that factor more. So certainly it depends on the transport mechanism and the exposure conditions in the structure is situated, whether it is a what kind of structure, if it is a water retaining structure or continuously alternate wetting, drying, it is happening or whatever it is. So it depends on that. And as he has said that whether it is a magnesium sulfate attack or whether it is a subsoil, if it is there, then sulfate attack, if it is below the ground. So then that particular test or transport mechanism which will cause this disease to the concrete or which will create a deterioration of the concrete which prevailing to predict that, or to, as said, qualitative, this will give you only a qualitative measure. And then depending upon what kind of concentration is there, then the quantitative measurement can be prescribed, like how many coulomb, if it is RCPT, is to be then, that has to be defined depending upon what kind of exposure and conditions are there, surrounding environment or conditions are there. And yes, that's why people design it. Nowadays, predictive tools, like people do mathematical modeling for designing the estimating 250 years, 200 years, 300 years, like that. People are using selecting the materials according to that all these different transport mechanism will work on that, or attack of all these attack mechanism will work on that. So nowadays, these are the predictive tools are available, and mathematical modeling is possible to design the life of the structure, whether you would like to have 300 years, 250 years. So some 250 years structures also has been defined. All structure has been designed, like statue of Shiva near Udaipur has been designed for 250 years of life. And accordingly, the metals have been selected, right? Just to add to that.
Yes, Dr. Hegde, would you like to say anything?
No, sir. It's okay.
No, let me put it this way. Since I have done this little bit of mathematical modeling on this subject, fundamentally there is only one thing related to durability of concrete. That is the moisture ingress. If Dr. Murari Ratnam said, moisture for alkali aggregate reaction, corrosion cannot occur if there is no moisture. Carbonation cannot occur if the relative humidity is between 55 to 65, it will occur most of the time. So corrosion also, moisture as well as oxygen is needed. Any durability reaction, because it occurs in the solution phase and water is the solvent. So fundamentally it is the moisture transport which is important. Now at the moment, largely the measures, as Dr. Anuj said, is all qualitative measures. Quantitative modeling has to look into moisture ingress into concrete. And I think sometime here only in CCR, even in their magazine, I have written and also said that, so wetting and drying of concrete is very important, and that's governed by the precipitation zones or climatic zones of the country. And what do you call the marine environment you can separate out, because there carbonation would not occur, but nothing else would occur. More probably fluoride induced corrosion may occur. So that modeling part, of course, is still in nascent stage. And what model available, let's say, used for in Europe and America, particularly with respect to chloride, that's not suitable in India, because they actually do it essentially for de-icing salt scenario, where chloride concentration remain constant on top of the bridge deck. In India, it will not be like that. There is no de-icing salt to use. So boundary conditions are India specific. And wrongly using these models, I have seen this being used in a mega project in this country, Delhi itself, wrongly used. So models should not be used wrongly used. We must understand the phenomena around us, and our code should look into, or code or anything should look into that scenario. So moisture ingress is the most important thing, and that your sorptivity is fine. Sorptivity has been empirically related to hydraulic diffusivity, which is a parameter which governs moisture in there. Otherwise, modeling at the moment, they are all in nascent stage. There are a number of them, claims, etc., not universally yet. Okay. So can we go to some other question?
Yeah, Mr. R.K. Jain wants to ask question. I think he has raised his hand.
Yes, Mr. Jain, yes, please, your question.
Is he mute? Please unmute.
Yeah, please unmute yourself.
Am I audible, sir?
Yeah.
Yes, you are audible
now.
Sir, my field is concrete roads. Dr. Morgan knows it well. My specific question is on water cement ratio. The first concrete road of India, Delhi Mathura Road, where I was project director and engineer, the water cement ratio was 0.42. These days, our modern consultants, with anything in their mind, they design water cement ratio 0.32, 0.34. Most of our roads have failed prematurely, but the one which I constructed, it is behaving even after 28 years. Question is, you had shown in the slides, sir, water cement ratio more than 0.4. It was 0.45. Water cement ratio we should keep for the concrete roads. It's a big question, sir, and our consultants have failed us.
I think in one of my slides I have shown.
Thank you, sir.
Yeah, one of my slides, when I am talking about the holistic design, etc., I mentioned that with a very low water cement ratio, the concrete has failed prematurely. I made a statement there. I think your example endorsed to that view.
Yes, sir. Yes, sir. To a large extent. So, what is we should keep for the concrete roads? That is my specific question, sir. We are building a lot of concrete roads in India.
No thumb rule.
Pardon, sir?
I said no thumb rule like that. Just a minute.
Yes, sir.
Pavement means it is flexural strength.
Yes, sir. Yes, sir.
Yeah. So the flexural strength at the moment, you call it pavement grade concrete, but linked to minimum M25. I think that's not a very correct practice. It would be. Why don't you grade the concrete according to the flexural strength?
So we are keeping minimum, sir, 4.5 MPa is the flexural strength.
So you call for concrete, call minimum 4.5 MPa, F 4.5 as a grade. The mixing up is there, and that's creating a problem.
No, okay. That is okay, sir. For that also.
And just a minute, develop a water cement ratio type of curves for your concrete, right? So there's no, minimum is okay. Minimum means the porosity and pore size porosity you would like to control.
Sir. Yes, sir. Yes, sir.
So that's according to Power's formula. If you look at it, it is simply W by C minus 0.317 divided by W plus H, hydration, degree of hydration, divided by W plus C plus, minus 1.17 divided by W by C plus 317, something like that. So Power's formula tells us about capillary porosity, it tells us about gel porosity, and it tells us about total porosity. But that would depend upon cement type and cement also. So the issue is not thumb rule based. You cannot base it onto thumb rule.
No, but there has to be some minimum value above that. We have to keep it because I have experienced it. 0.42 has worked very well. 28 years, whereas people designing at 0.3.
No, that's one of my mysteries saying, "Sab, aapko kuch pata nahi hai. Main 50 saal se kaam kar raha hu." No, this is not the thing. You go to the scientific system, right? So 32 failed. 0.32. Why did it fail? Fail on what?
I don't know, sir. This is my question.
No, but why did it fail? I mean, where is the failure? What is the type of failure?
I feel the less of water cement ratio.
No. What is the manifestation of failure?
Well, there's a lot of cracks. It has failed.
That might be shrinkage cracks.
No,
Thermal
not
cracks.
shrinkage, sir. I know, sir,
Then-
cracks, they are not shrinkage cracks, they are deep,
Then-
full depth cracks, they are partial depth cracks, there are all types of
No,
cracks.
no, even full depth crack can shrinkage in a thin
Shrinkage
section.
cracks, yeah.
No, that develops with time, so it develops, it goes on propagating. I know.
Actually, this has to be analyzed. All right.
Sir, let me tell your good self, all these codes of concrete roads, Dr. Moge knows, have been written by me in India.
That doesn't matter
15
anything.
years.
It is all copied from abroad. Please
No,
don't call him.
no, Dr.
Don't tell me
Bhattacharya, no, Dr. Bhattacharya, no copy, sir. Kindly,
who did the research in India? Who did the research in India?
Well, that is up to you. What IITs are
Nobody
doing.
has. No, it's not that. I'm not saying.
We are in field, sir. No, let us not get into that. My question
Anyway,
is,
I think we'll not discuss this. No, personally, you can talk to me. I can tell you, India, nobody has done research. IS 456 is ditto copy from CP 110. 8110. CP, British code 8110. What are you talking of?
Sir,
have you done any? Please, whole of this country, we have not produced so much of research material to produce a code. And the code that we have actually developed based on some work in 1960s, that's Mixed Design Code 10262, I think this is not even acceptable.
That is all right, sir. That is all right, sir. But why saying so?
IRC are also copied from either IS or similar codes elsewhere. Because the quantum of research we are doing is very little. So unless you have investigated the crack, do not say that it is because of 0.32. You have not investigated that crack properly. Why that crack has come?
Well, I don't want to get into that, sir. That is all right.
So please don't ask this question. Please.
Thank you very much. No, I will keep on asking till I find
no,
an answer.
Ask to me personally. You can ask or send me an email.
Yes.
I'll answer.
I will email to your good self. And then seek time. I am in Gurgaon only. At your convenience, kindly guide me.
Sure,
this is my humble
I'll do that.
Thank you, sir.
Now I'd called Dr. Rajmane to make some comments he has been putting. Dr. Rajmane, you are around? Rajmane Saab?
Am I audible now?
Yes, you are audible, very much audible. We'd like to hear from you.
No, actually a lot of discussions have taken place. I want to put some points here. I know Professor Bhattacharya and also Dr. Hegde and others also, but I want to put some points from the practical side point of view. Strength and durability. Somebody said strength is not a parameter for durability. I agree with you, but strength should be taken as a parameter on the site, then only durability will come. M20, M25 is not the strength at all for durability. So you should provide M40. Don't worry about structural design. So when you want to provide M40, then only quality control will come on the normal concrete levels. So M60 it is provided automatically. Quality control on the concrete making is there. It will come out all right. So strength, minimum strength should be raised for the durability for quality control purpose, not for the structural design. That's what my point. RCPT already Dr. Bhattacharya raised many points. Don't use ASTM values at all. Don't use ASTM values. They are meant for only OPC concretes. And we are making concretes without OPC. We are adding a lot of ACM. There is no code yet made available for that kind of concrete at all. So whiting is made only for, so please don't use those RCPT values. Okay, this is the most, and instead of, as Dr. Bhattacharya told, it is an electrical resistance test. So electrical resistance can be obtained by so many methods. So please go for chloride diffusion coefficient values. Chloride diffusion coefficient values does not depend upon the electrical resistance. It is measurement wholesome. So how much chlorides enter, it is a parameter. Okay, and alkali aggregate reaction. Very clearly, it is because of the high alkali content in the concrete. There is no doubt in that. Okay, and it is because of the reactive silica or reactive minerals in the aggregate. Now, only question is, I have seen also in many nuclear plants, they use a low alkali cement, so that the pH produces not near to the 14 or 13.8 or something. That's all. Low alkali cements are made by the cement plant specifically also, if it is required. So there is no question of thinking very wrong, difficult about alkali reaction. As Bhattacharya said, it is not common situation, but important situation, as Dr. Ratnam was telling. So it can be taken easily by the low alkali cement and cementitious material, SCMs. Okay, and coming to the durability tests for the durability, all these air permeability or water permeability, all these are not meant for the site conditions. Even water permeability, ISAT, initial surface, all these are meant for only surface measurement. Our cover has to be, say, 20 mm. This is affected only last 5 mm. If the 5 mm concrete is bad, another 15 mm is available. All the tests meant for only the initial 5 mm thickness, around about that. So, durability test has not come to the site condition yet properly as much as the strength has come. Strength is also a lot of questions are there, but at least strength is accepted as a parameter for quality control on the site because it is more related to the concretion by a lot of tests. These are the points I wanted to add. Some more points we can discuss separately also. Coming to that UHPC. UHPC, as Dr. Bhatt just told, the cement content is high. Why? And also it is already answered. The durability is so high. And it's no shrinkage at all. High cement content is related to shrinkage. No, there's no shrinkage in UHPC. So UHPC is not a problem in the sense durability is already increased. But the only thing making UHPC on the site is to be done very carefully and is to be assured.
Not at the site.
Not at
the site at all.
Yes.
Not at the site at all. It is precast.
Precast units will be fantastic. Okay, coming to the green concrete, geopolymer concrete. Geopolymer concrete is the most useful green concrete. Only issue is, I feel, having worked for so many years, it should not be on the site. Impossible. We should use it only in the precast industry where the grade of concrete is M40 and above. M25, M30, it will not simply be feasible technically or not technically, economically. Nobody will take it. M40 and above, it is likely to be near to the cost of the ordinary concrete, M40 and above. So, and also only for precast industry. And if precast industry can come together and work on the use of geopolymer, it will make the concrete easily greener. There is no problem at all. Information is available, knowledge is available. There is no question of that at all. Only implementation in a proper place. And that's what I wanted. In carbonation, already Dr. Bhattacharya told about the moisture movement. Without moisture, no reaction takes place. No durability problem. So if the concrete cover is very big, most important, very big as per the requirement by so many organizations, and good also, not only big, good. That's all. It will take care of durability automatically. No question of any test at all. And you cannot do durability test on the site. This is my concerned view. Professor Bhattacharya can add something or even...
no, I'm not going to add anything. I'm going to give Mr. Kalidas Nateri a chance to ask a question, or there are some questions he has put in. Yes, if he is, if he is present, then he can also speak. That would be good because he has several questions. Mr. Kalidas Nateri, yeah, he is there. Right. Please go ahead. Yeah.
Good evening, everybody.
Good evening.
The basic point is porosity, which can be reduced through reduction of water cement ratio in association with complementary cement materials. So once this is...
Yes, please go ahead.
Low alkali cement, permeability issue, and passivity film, so many issues can be addressed once the porosity is addressed. So nowadays we have 4th generation admixtures which are facilitating reduction of water cement ratio to as low as 0.3 and below. And thanks to Dr. Bishwajit, you have rightly mentioned the durability issues are not because of reduction in water cement ratio. It is because of various other concrete preparation techniques where due precautions have been not taken care, and the composition of concrete is not synthesized in the right manner, taking advantage of complementary cement materials. So my request is Dr. Hegde rightly compared surplus lime to surplus sugar. He would have continued to say that the fly ash is the insulin to take care of the sugar. The moment you address the surplus lime and engage it into hydrated mineralogy, akin to the mineralogy of C3S and C2S, thousands of issues are addressed. First of all, the permeability will reduce, the porosity will reduce, and strength will improve, so many things. And the deleterious effects of the lime in association with atmospheric pollutants is drastically reduced. So my submission is to deal with the durability. We should deal more with complementary cement materials and reduction of water cement ratio, and project those data as we have been doing it in the field as well as in the lab. So this is my submission.
Yeah.
Thank you very much, Dr. Bishwajit.
Okay, so anybody raising their hand? Otherwise, I'll go to Mr. Subramanian Sivaraman, I think. Is he there? Or anybody raised hand for asking a question?
So next we have Mr. Vikram Kumar.
Okay, so we'll go to Vikram Kumar and then we'll go to Subramanian. I think Sivaraman he should be. The full name is not seen. So first let's hear Vikram Kumar.
Yeah, good evening, everyone. I would be more interested in durable structures. That is, of course, a part of durable concrete. So I would request if you can throw some light on the methods available for assessment or of residual life of structures. Because whenever we design, say for 100 years or 150 years or 50 years, is there any method to quantify the or monitor the age of structure at any stage or the residual life? Thanks.
Well, anybody would like to react? We have done some work on this. So if anybody has a question, something, then they can go ahead. Otherwise, we'll tell what we did.
Sir, you have already answered partially this question in a previous question also. So you can continue with that because you already answered for that. You have
now, actually, what he's saying is residual life.
Yeah.
Yeah. So there are two things we did actually. There's one of our student. I mean, Mr. Dhawan. If you know him, many of you might be knowing him. He attends most of the conferences and asks questions also. 77 years old, who did his PhD with us. Now, what we did was we actually tried to find out the damages in the structure due to river corrosion, simulated it, and then tried to find out the return period of wind which it can withstand, because you are looking from the structural design point of view, right? Or return period of the earthquake which it can withstand if many of the elements, because durability design is related to elements, not to the whole structure. One element will deteriorate, all elements will not deteriorate simultaneously. By the way, if an element fails in its service life, because service life is defined, is some sort of serviceability limit failure, appearance of first crack or something of that kind, whole structure will not collapse. Earthquake can cause damages to many structure, and if the design is improper, it can even cause some collapse. But durability is a slow process related deterioration, degradation of material, deterioration, they are slow processes. So some element will degrade. So let us say n number of elements have degraded. Then what is the structural capacity? And what is the return period of wind it can withstand? So that's the residual expected service life of a structure you can thought of. So durability, no, service life is related to when it is related to durability. It is a slow process. Everything collapse do not occur with that. While your wind load or earthquake load, if improperly designed, can lead to collapse of the structure. Philosophy is that some element may fail in extreme earthquake, right? Because a lot of ductility is provided, or wind horizontal load, wind load, but the whole structure should not collapse. But durability is much slower process actually. Structure collapse doesn't occur, but you will have loss of cost of maintenance. So we try to look into this issue, and that's how we looked into. Does it answer your question or something more you have, Mr. Vikram Kumar?
Hello. Yeah.
Yeah. Yeah, you are.
Okay. Yeah, to some extent, I have been. I mean, my question has been answered. Actually, I was just looking, is there any way to quantify that? If considering that all the, there is no abnormal wind load or earthquake, whatever we have designed or whatever we have considered at the time of design,
you have to
basis that.
actually investigate onto the structure. You have to investigate in the structure, find out the degree of damage, right?
Yeah.
And today you have got different techniques of doing that. For example, you can resort to what is called, piezo sensors, sensing. There are other kind of sensing devices. PZT gives us damages. So by electromechanical impedance techniques, so current state of affair of the structure you can find out, and then see what is its capacity remaining. So unless we know the current state, we can't do that. So, situation not at the beginning, but after some years.
But if we are able to measure all the critical parameters that you have said, like the durability parameters and other deflections and or crack propagation and all, but we can, is there any model to combine all these parameters and come at a number which can be used as a expected service life for that, sir?
We can come at a number, but it is not a kind of there's no software or anything of that kind. What we did was, we collected for every element, and then we said that, okay, these are the critical members. If they are affected, they are damaged, what will be their structural capacity at the moment? So for example, 20% of the bars have gone in a given structure. Or then obviously you'll repair it, but if you have not repaired, what is the scenario? So it can be estimated. There are, you have to apply. There are no ready-made software. We have not come across that.
Okay, sir.
But it's a PhD project, as I said.
Thank you, sir. Thanks a lot.
Yeah. So, anybody would like to add on to this? Anuj, Dr. Anuj.
I think, what I can only add to it, sir, that we can go with the proper evaluation of the structures, take out some cores, find out the, let's say, present existing chloride levels or the chloride profiling, what we call as. And with that chloride profiling, and if we have information about the chloride concentration at the surface, perhaps we can find out this diffusion coefficient of the chlorides. And based on that, using the theoretical models, perhaps we can estimate the residual service life. But doing that would be very, very, let's say, a crude thing. But yes, in my opinion, we can resort to such a thing. But again, before that, we had to establish what is the primary, let's say, deterioration mechanism for the corrosion, if at all corrosions are there, what type of cracks are available, and let's say, if any repairs have been undertaken in past, so what is the impact of those repairs? So it is not a very simple process.
No, not at all. In fact, in Indian scenario, as I said, most of the places, the chloride comes from ingredients in the most of water. Away from the seashore. We investigated what the cases in seashore also. Unfortunately, there also we found internal chloride rather than coming from the wind, which brings in the chloride aerosol. So there are complications involved. It's not an easy thing. Okay.
Yeah, I would like to say on this. Say, for example, residual life is that already Dr. Bhattacharya and Dr. Anuj has explained it. But what if we are looking at it basically to restore the life of the structure for which it is designed?
Back, yes.
And so that's why the strengthening of that structure, that is more become important, at least to complete the life of the structure or enhance the life of the structure further. Because at that point of time, like Dr. Bhattacharya has said, we will assess the condition of the structure and we'll come to know that it is going to last for this many years, 20 years, looking at the distress condition. But then what is aim? Aim is, again, what is objective? Objective is to strengthen the structure to complete its service life. So we should work on that, right? So residual life, you may come to know that building may last for another 20 years, but really it is a complex phenomena. Like suppose road intensity has increased, or some kind of a forces which are coming in other direction, earthquake or this thing will come in a different way. So certainly the design life has to be fulfilled. That's what that's more important.
Yeah, that's right. That's right. It's called intended design life,
Yeah.
100
Yes.
years, if we had the intention. So anyway, let's go to question by Subramanian Sivaraman, if he's there. He asked a question. Yes, please, go ahead. Sivaramakrishnan, yes, that's right.
Good evening,
okay.
all. Am I audible?
Yes.
Yes, you are audible.
Yes.
Hello.
Yes, you
Am
are
I audible,
audible,
sir?
Please go ahead.
I want to ask, what are we doing with the cement kiln dust in India? Is it effectively reused or dumped in landfill? My second question is like your thoughts on use of carbon nanotubes and graphene.
I will answer the first question. The CKD, some parts of CKD is being used in the cement mills, in the cement plants, but with very small percentage. But its usage is very, very slow. Is it okay for you, Mr. Sivaraman? Subramanian?
Yeah, sorry, sir. I think there was some issue with my audio in between.
Now, what I mentioned was, Mr. Subramanian, the CKD dust, it cannot be used in a big way or in huge quantities. The small quantity is being used in some of the cement plants in the cement mill.
Okay.
Or because it is not dumped in anywhere in the cement plant, it will be poured in the limestone stacker, where we are stacking limestone in the pile.
Yeah.
So we are using along with the limestone pile. It is not being thrown anywhere in the plant or dumped anywhere.
Thank you. I had another question. I don't know. It was audible.
Yeah, you are audible.
No, I was asking about like your thoughts on use of carbon nanotubes and graphene.
I think Bhattacharya sir can throw some light.
Sir, you are on mute.
Mute.
Dr. Bhattacharya, you are on mute.
Yeah. We were trying to use graphene in the research level. And people have been also trying to use carbon nanotube in the research level. Right, SCRC Madras, they have tried to use carbon nanotubes, and graphene we tried to use in pavement for helipad for defense, something of that kind. So graphene, oxide basically. So these are in research stage. I don't think this has gone to the field as yet.
Yes.
It will take time to go into the field.
Exactly.
Thank you so much, sir.
Anybody raised hand for a question? Then we'll go to Sunit after that. Sunit Gupta is there. His question was there. Yes. Anybody is raising?
So we have Mr. Anand Jain.
Yes, Mr. Yes, allow him to. Anand Jain, allow him to speak. You are muted, Mr. Jain.
Sir,
mute yourself.
Am I audible, sir?
Yeah.
Now you are audible. Yes.
First of all, sir, greetings to Dr. Bhattacharya. He has been our professor at the IIT Delhi, and Dr. Hegde, who has been my colleague, and Dr. Manoj Maheshwari and Mr. Moghe, all of you, for having such a wonderful webinar.
Thank you, sir.
I first of all greet all of you. And my only thing I want to add, sir, is that there is adequate knowledge and adequate research work, and also the specifications, as Dr. Bhattacharya said, whether it is BS standard or ACI or ASTM or Indian standards or EN, all of them are elaborately giving the specifications. But many times I have seen that the actual tender specifications are not framed as per the codal provisions. And many times now the bullet trains, sir, it is going on here. And nowhere any corrosion inhibitor is provided in that while it is passing through the coastal area. And once the contract specifications are finalized, there is no scope further to add anything because they say it has become a sacrosanct thing. So I think somewhere the construction techniques we need to improve a lot in case of concrete. The material quality which is available, whether it is the crust aggregate, whether it is, they need to be quite a bit, lot of changes are required. And though a lot of progress has been made in this, and it is very good that we are having much better finish and much better durable structures. But still, we need to have some continuous efforts in that direction. And the specifications, I think, sir, in durability in the tender document, what has been written is the most important part that ensures the durability. So many times these tender specifications are lacking. CIDC was given this to standardize the tender specifications, but if you see a tender with the railways still are not allowing the use of the fly ash, use of the supplementary, they want only OPC. So this kind of dichotomy, I think it needs to be addressed.
Yes. Yes, I suppose we appreciate that all.
Correct.
Yes, actually, so the actual practice is, you know, there's a lot of difficulty, there are a lot of efficiencies existing.
And one thing more I want to add, sir, that was a very interesting discussion on the lower water cement ratio. My experience a little bit on the subject is that lower water cement ratio will not reduce the durability. Only thing it can do is that the gain of long-term strength will be reduced. If we have water cement ratio lower, then the initial strength and the strength up to 28 days will be much higher than comparative to the 56 days and 90 days. If we have little higher water cement ratio, say 0.36 or 0.4 in that range, the gain of strength at a later date may be more. But in no way the lower water cement ratio can reduce the durability of concrete. Secondly, at lower water cement ratio, some of the cementitious material may remain unhydrated. It may not hydrate fully, but it will have the mechanical and packing effect at the same time, and it will be useful in reducing the porosity and permeability both.
Yes, yes. Anyway, anybody else raise their hand? There are some questions here, of course. I see one from Sunit Gupta. What is your question? Sunit Gupta, are you here? Sunit is there? No.
No, sir.
He's gone. Okay, he raised a question here and then gone. Nitesh Sharma, I think he came already, is it? Yeah, his question has been answered. Concrete should be designed for strength, for durability, not strength. No, both. Then there is Rakesh Patel. Okay, it's only thanked everybody. And then Aditya Pandey. Would you like to speak out your question, Mr. Pandey? Is he there?
He's not here, sir. He's not here.
All right. Tushar Wankade, he says, what is about using curing compound? Are you around to elaborate your question? Yes, please, Wankade. Mr. Wankade, please go ahead. Mr. Tushar Wankade.
Hello, sir. Am I audible?
Yeah. Yes.
Yes, sir. My question is, what is your experience about using of curing compound? It is safe or not for the high-rise structural building? And second thing is, we are using curing compound at on-site column portion. When I casted the cube, we put them in water tank. So it is good or not?
Any practical answer for this? We have laboratory answers.
No, sir. Yes, sir. We are using these curing compounds extensively for our construction works. What is very important is about the selection of the right curing compound. The efficiency should be more than 80%. It is true that we cannot get exactly the similar, let's say, conditions what we get under water curing. But yes, this is where we cannot use water curing. Best curing is the water curing, ponding of water. But if that condition is not available due to the site conditions, as you mentioned about the high-rise buildings, you can safely go with the curing compounds, provided let's say, identify and you are using the right compound.
Yes, this is very important, because if you use a wax-based compound, wax-based curing compound in Delhi 65 degree centigrade exposed, surface temperature, because 45 will be air temperature, radiation coming on top of it, the wax will melt, it will peel off much before actually it is supposed to peel off. And I had to handle a situation of this in one of the major projects in Delhi, and it all cracked because of no curing. So you have to select the right compound, but it is, as Dr. Anuj said, it is not as good as ponding, or let us say if it is a precast segment of box girder or tunnel lining, then fogging, sprinkling water throughout, there's no alternative to that. There's no alternative. It might be costly, but this would be still a good job. You design it for a slightly higher strength, knowing that it will not give you as good as the strength on 7 or 3 or 28 days, maybe particularly 3 or 7 days, as much as it would have been in ponding. So you can tinker with that, play, do an experiment in the site, can use it, but got to use the right curing compound, otherwise it will be a disaster.
Okay, sir. Thank you so much.
Anybody else raising their hand?
So, Mr. Srinivas.
Yes, his question is also here. Srinivas Kutumbale, am I right?
Yes, sir.
Yes, please go ahead. I was about to call him next.
I have typed my question. These days, I understand that a lot of waste plastic and garbage is used as fuel while making the clinker. Does it have any effect on the quality of cement or clinker?
Dr. Hegde will be the right person to answer that.
Yes. Now it is being used. Your question, is quite difficult to answer, because cement plant is not so matured enough to handle the plastics and other municipal waste or RDF, whatever it is. But cement plant is striving hard, because they have to somewhere balance the chemistry of fuels, chemistry of raw mix, and the kiln operating conditions, etc., etc. So at present, I think the usage is on the very, very smaller level. So it is at present, it is not hampering. But yes, because all these chemical compounds, volatiles are there, and pollution control people will come and measure the atmosphere, NOx, SOx, all these things are there. So at present, it is not hampering on the quality of cement, okay, because it is the TSR percentage is very, very small, maybe less than 10%, vis-a-vis around 40-45% in the Western countries. So we have to go a long way. At present, it is not hampering too much, but sometimes cement plants, tend to add more alternate fuels like all these materials. Sometimes it will derail the operating conditions or operating parameters of the kiln, and they have to come back to the smaller level so that they have to continue to produce good quality of clinker. So
I am from Indore, and Indore has the most modern waste garbage segregation plant. And Indore is earning about 20 to 25 crores a year from the selling the waste to cement plants.
Yes.
So they are using it as a fuel.
Yes. It is being used in all the cement plants. If you go to Jaipur side, I think Ultratech cement we started using first of this municipality waste. Ultratech has also put up a plant to make the segregation and making the briquettes of municipal waste and transport it to Vikram Cement Works and Aditya Cement Works. So many cement plants have followed the footprint, and I think same thing is happening in Indore also. It is happening everywhere. All big cities are selling to the cement plants wherever it is possible, because it is negative cost for them, negative fuel cost for the cement plant. But they have to get the maturity still. That maturity level has not come. They have not mastered fully to take to the higher percentage of usage.
Well, I have the experience of visiting 2 cement pens because I was evaluating them for sustainable use and things like that on their own request. Holcim's 2 plants. Now, of course, it is a different owner. Wadi of SEC. And Ambuja Nagar of Ambuja Cement. Yes. So Wadi plant, I remember, they have a lab. So all the material which comes in, the waste material which comes in, they test it for its toxicity, because it can lead to many toxic discharge to the atmosphere. So therefore they discard those out. So there is a process involved. Have a laboratory, they store them somewhere, discard half of them, good lot of them they use as alternate fuel. So as Dr. Hegre said, there is an attempt to use as much as possible, because it saves onto your carbon issue in accounting, because this carbon has been already accounted for somewhere else, right? So now you are using it and you are saving onto pet coke or whatever you are using as the fossil fuel in the cement kiln. So therefore there is an attempt, but how much percentage you can do, it will depend upon how you segregate everything put together.
Dumle sir, there is a lot of in our laboratory. There are FR labs are there, and they have all these equipment. So though they analyze it completely, and depending upon without that disturbing the properties of cement, these FR are used and to that percentage, because there may be a different kind of matters which will be there. Certainly all these things, because very well equipped FR labs are there, alternate fuel research labs are there in the cement plant. So those is being analyzed and then only it is being put into use, because all the radical analysis, whatever it is, because ultimately it is an incineration process, and after that whatever residue which will be there, because it will get burnt into that, but certainly it will have an effect on the oxide composition or not, because it is also like a concrete mix design, raw mix design is being done. So all these things are being done, because otherwise the required level of this permissible whatever oxide should not exceed. So certainly there is a process in that.
And nowadays, it is a lot of cost effectiveness for the cement plant. For example, earlier the imported coal cost was 8,000 rupees per ton of coal. Now I think it has gone more than 22,000 rupees. And even petcoke was around 10,000 rupees, I think one year ago. Now it has gone to 23,000 rupees, and that is so volatile. So whatever substitution takes place by using alternate fuels, that much of direct saving for the cement plant. Suppose it replaces 10% of the fossil fuel, that much of the saving will be there, and it is using waste is a negative cost for the cement plant people, and the waste generated by many agencies will pay to the cement plant for incineration.
Yes.
Mr. Hegde has already informed that Ultratech is using plastic waste and this thing. And Ultratech is one of rather the best cement available in the country. I am using Ultratech. I just asked this question for my other friends to convey them. वो बोलते हो कचरा डाल रहे हैं उसमें सीमेंट बनाने में, वो सीमेंट की ताकत अच्छी नहीं है. That was the issue, and that's why I asked this question.
Okay, thank you.
For your information, Srinivas sir, I think Jain Saab and myself, we have taken all pain, to set the quality of Ultratech cement with written commitment from the plant side. I think that we are doing for the first time, and I think one way, directly or indirectly, we both are responsible to set the quality standard of Ultratech cement.
कचरा जलाने के बाद कचरा नहीं रहता है.
In this period of competition, the competitor can raise any issue. You know that.
Yeah, that's right.
As a layman, one should understand that cement comes under BIS certification, so it has to mandatorily, let's say, comply with all the parameters there.
Correct.
So whatever they do, end of the day, the parameters for acceptance has to be complied.
Yes, specification has to be maintained. Yes. So we are running out of, I think we have already 20 minutes up, but there's one Lakshmi Ganesh Saride. Some question. Are you around? Lakshmi Ganesh Saride? Yes, he is there. So please go ahead with your question.
Am I audible, sir?
Yeah. Yes, you are.
Sir, actually, my doubt is generally we used to our foundations are made in are kept in soil, but if the soil have more nitrogen or phosphorus contents, especially in our area, we have more this type of contents in soil. Will that nitrogen or phosphorus or potassium levels in soil will affect the durability of the foundation? How they'll affect? Is there any chances of I mean, a degradation of concrete due to these contents?
Yes. Yes, Mogi Sahab, bataiye.
Yeah. What here Dr. Hegde has shown is in his slide. Actually, if it is in the foundation, in the sulfates are present, in the concentration is there, and actually sulfates react with C3A, which is in the cement. So it reacts with C3A in the cement and forms a yttringite. And because of that is yttringite, if there are magnesium sulfate, then it forms thomsite. So again, yttringite, again it gets converted into yttringite. So basically, yttringite is formed because of the reaction of these soluble sulfate, which are present in the soil with C3A content. They react with that and gives rise to yttringite. And because of that, actually, yttringite is a expansive formation. And because of that, actually, there will be expansion will take place. And because of that, the stresses are created and cracks will develop. And that is called as sulfate attack. So similarly, whether it is a magnesium sulfate or sodium sulfate, those are going to act on the C3A, and certainly it is going to give a sulfate attack. And because of that, further once cracks will be developed, because there will be expansion will happen in the concrete mass. And because of that, actually, it becomes further what you can say pathway for the other pollutants or moisture movement, which will go and will reach to the corrosion, and which will further start another corrosion process. So sulfate attack will lead to and similarly, that's why people use it many times. People recommend it, that sulfate resisting cement, especially when the sulfatic soils are there. But that's why if you'll see the IS 456 table, they have given a permissible values of SO3, which are present in the groundwater or soil in part per million, and then which type of cement is to be used. But what is important is, again, people use it sometimes sulfate resisting cement for having the sulfate resisting action. But especially hot and humid climate, whenever it is there, the chloride attack is also very dominant in case of hot and humid climate. So we'll have to see that's both the attack mechanism, like as what is the property of cement and which environment it is being placed, at which situation it is being placed. We'll have to see and selection of cementitious material, whether blended cement or cement having C3A content, and that's why people use cement C3A content restricting between 5 to 8%. So to have a moderate sulfate resisting properties, and simultaneously it will have concrete will have a better resistance for chloride. So I think if
I have three questions here. Right, if Mr. Lakshmi Ganesh is satisfied, then I can go to them. Yes, Mr. Lakshmi Ganesh.
Yes, sir. Yes, sir. Okay.
There is one from Dr. Karade. Are you around? Karade Saab? I suppose he's the Dr. Karade from CBRI. Sukhdev Karade?
No, sir, he's not here.
Okay, so he's gone. Then one from Mr. Amitabh Kar. No?
No, sir, he's not here.
Okay. Mr. Anupam Haldar. Not there?
Not there, sir.
Okay. Rakesh Patel. Mr. Rakesh Patel.
He has left, sir.
So I think if there is any hand raised, we can listen to them, because if they're not there, there's no point discussing those questions unless it's very serious question. I didn't see any serious question really. I mean, very challenging question. Not really. No. No. I think if there's anybody has raised hand, then fine. Otherwise, I think we'd like to call it a day. Aditya Pandey, is he around? No.
No, sir.
He's talking about slip form construction. Anyway, so if there is anybody who has raised his hand, we'd like to attend.
Sir, if I may,
Yeah,
since
go
there are so many questions and some of them have left with good questions, but they are not here to hear them. So what we can do is we will take up these questions and send it across the panel. And you all from the panel can segregate those questions as per your expertise, answer them as per your time, of course, and your ease. And then we will take up those answers which you have given us and publish them in our upcoming magazine, so that people can have, our readership can have a look at it as well. And those who have missed out on these answers can have a look as well, if you think that it is feasible.
Yeah, if take only those who did not come here and whose answers have not been addressed. Otherwise, there will be too many, and it will be difficult for the panelists also to take out their time and answer all of them.
Sure, sir. Sure. Thank you.
Right. Okay. So if there's nothing, then I hand it over to you.
Okay, sir.
We would like to express our gratitude to all esteemed delegates of the webinar for their presence and contribution to make this a great success. We were enlightened with the knowledge disseminated through the discussion. This was a true learning experience for us all. We extend our regards to the industry and participants who have joined us today. We hope the session was fruitful. We thank you all for joining this webinar. Stay tuned for our upcoming webinar on 16th December, Friday. Our webinar topic is Bridge Failure, Lessons and Remedies. Once again, thank you all for coming.
Right. Thank you very much. Thanks everyone. Thanks everyone.
Thank you
It
so
has been
much.
nice to be together.
Thank you.
Good day.
Thank you.
Good
Yeah. Take care, sir.
Thank you.
Thank you. Bye.
Dr. Bhattacharya. Thank you.
Right then. Okay. Thanks, Pravir, Bhattacharya, and the team. Good day.
Thank you so much, sir. Thank you all.
Right.
Yeah. Thank you to Prabir and his team.
Right. Good night. Okay. Good night. Bye bye. So I'm
Bye,
leaving.
bye.
Leaving.
Okay. Bye. Take care.